Here, what we have today is recursive sequences. We're gonna elaborate on recursive sequences in today's lesson. What we've already learned about it, what type of sequences we're dealing with, and as of now, we're going to be dealing with basically three types of sequences. So the sequences we're going to be doing are arithmetic, which have a common difference, geometric, sorry, that's common difference D, which have a common ratio R, and recursive, which are based on the term before. And with recursive, it could be arithmetic, it could be geometric, or it could be just a straight recursive sequence, as we will see today. So three types of sequences that we need to be comfortable with, of finding the next terms, of finding patterns. It's not necessarily a function because of the fact that it's not continuous. So in a sequence, then the difference really between what is a sequence? A sequence is like a function, except it's discrete. So you only have the first term, the second term, the third term, the fourth term. You don't have x equals 1.5, because you can't have that. It'd be you could theoretically write it as a function, but the understanding is that the input values can only be discrete values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and refer to those as those terms. As such, we write them with the letter n instead of the letter x, so we don't say y equals a function of x. We typically think of it as a equals a function of n. Or we can even talk about f as a function of n. So arithmetic. And right now, like I said, I'm trying to get a little bit of review. Some of you wanted to see a little bit more hands-on piece. So when we talk about the terms A1, A2, A3, ... If we take A2 minus A1, we get some type of common difference. Actually, let me write one more, A4, so I can just do it. A4, and then ... If we take A3 minus A2, we would get some difference. And if we took A4 minus A3, we would get some difference. And the key here is that the difference, that when we subtract any term in the sequence by its previous term, the difference is the same. Okay, the difference is the same. There's a common difference. So we have the function an equals the first term plus n minus 1 times that common difference, and this is the formula that we use. And then you can have that. You should have that written there for you to be able to see that formula. I hope that you understand why that formula is such that it is, and as we've explained in the prior classes. You do not have to build the formula yourself, though. The whole n minus 1, it's just like y equals mx plus b, where the a1 is like your b, is like your y-intercept, but we back off a term. So we use, instead of, we use n minus 1 versus just straight regular n, because a1 isn't really my y-intercept, it's really my first term. It's like when x equals 1. But overall, this is the formula that works with that. So for example, if I have 5, 9, 13, 17, dot, 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 dot. If I wanted to confirm that this is an arithmetic, if I subtract here, I get 4. Subtract here, I get 4. I get plus 4, plus 4, plus 4. So that tells me is arithmetic. With D equals 4. And therefore, my sequence is what? How do I write this arithmetic sequence? Can somebody help me out, please?
You first have to put 5.
Good.
Plus.
Mm-hmm.
And then parentheses. N minus 1 times close parentheses times 4.
Perfect. Perfect. And if I wanted the 8th term, can somebody help me out with now finding out the 8th term?
You have to change the N for the 8.
Good. Sorry about that. So 5 plus 8 minus 1 times 4. And at this point, we can use our graphing calculators. We can use Desmos. We get A sub 8. I'll do a little bit more by hand. 7 times 4, which is 5 plus 28. So A sub 8, or the 8th term, would have been or is 33. Okay. So that's arithmetic. Basically, that's what we did with arithmetic. Now we also what we also did with arithmetic is that if I told you the 8th term, all right, and I said the 8th term is, just because I can try to want to review everything we've done, and like I said, this is all review. If I said what term is 37? Now, of course, I think it's kind of obvious it's going to be the 9th term, but I wanted to do this. So just to show you. So we would set 37 equal to 5 plus n minus 1 times 4. That's the difference between this problem over here and this problem over here. Instead of plugging in 8 for n, we substitute 37 for an, because that's what the n term means, that's a term. And then we do algebra. So 37 equals 5 plus, well, and I'm actually going to solve this one just a little bit different algebraically, so that here's another way of doing this same problem algebraically. Algebra can be done in many different steps. Good algebra is good algebra. So some people do not feel comfortable. You could distribute the 4 if you had wanted to, but it's not necessarily needed. You can actually use the order of operations as it is written right now. So we can subtract 5. We get 32 equals n minus 1 times 4. Then we can divide by 4. We get 8 equals n minus 1. And then we can add 1 to both sides, and we get 9, n equals 9. So the 9th term. So that's everything I asked of you from arithmetic sequences. That was basically what we did over 3 days of lessons. So I really try to stretch that out, hammer it home, and give you the practice. Nothing here, again, is new in review. It's new, it's review. I'm hoping that if it didn't click with you the first time, that hopefully it is clicking for you now. Next we go to geometric sequences. And much like it, we have A1, A2, A3, A4, dot, 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 dot. And instead of subtracting the terms, if we take any term and we divide it by its previous term, we get some value r. So A3 over A2, r, A4 over A3. Now, it doesn't matter. Now, if I tell you it's geometric, you don't have to do it all 3 times or however many times there are. You don't have to divide every single time. You really just have to take any term and divide it by its previous. If you're trying to determine if it's arithmetic or geometric or neither, you have to check every one. So when you're trying to determine if it's what type of sequence it is, you do have to check every term. But if I tell you it's geometric, you know that there's just an r. So a sub n is equal to the formula being a sub 1 times r to the n minus 1. And that's how we write the formula for arithmetic. So for example, if I gave you, and let me do something with fractions because I know that was probably where you're having the problems. 5 halves, 5 fourths, 5 eighths, dot, 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 dot. If I take any, and I tell you that this is geometric, we take any term and we divide it by the previous term, so 5 halves over 5. Now some of you try to think, what can I multiply? And if you can do that mental math in your head, you can kind of figure out what r is in this problem. I just want to show you this part way. So this is 5 halves times, you keep the 5 halves, you change it to multiplication, and then you flip what you were dividing by. Keep, change, flip. So 5 halves divided by 5 becomes 5 halves times 1/5. And you can just think of 5 as 5 over 1 as its own fraction like that. Keep the 5 halves, change to multiplication, flip what you were dividing by, which gives me 1/2. So can somebody tell me what the sequence is here?
The sequence will be 5 parentheses 1/2 close parentheses, and then n minus 1.
To the power of n minus 1, yes.
Power.
Perfect. If I said, what is the 8th term? Okay, if I said, yeah.
The n by the 8th.
Good, so 5 times 1/2 to the 8 minus 1. And we should probably just go directly to a calculator on this part. So, and you will get a decimal. So it would be 5 parentheses 1 divided by 2. Fractions are just division. Close parentheses raised to the 8 minus 1. Or you could have just typed in 7. And we get 0.0390625. If you're wondering what that is as a fraction, you can hit, when you have these calculators, if you have a graphic calculator, you can hit math, enter, and it'll give you the number as a fraction, which is 5 over 128. But if I'm just telling you what is the term and we can round it, it's okay to use 0.039. That's good enough for our work. So 0.039 would be appropriate. This is 5 over 128. If you want to be more precise, both of them are good. I don't ask you for. We're not going to try to do the algebra um, with if I told you what if I told you what term is so and so value. We're not going to do that with geometrics. The main reasoning is there's just such a wide variety of math skills because we have grade levels 9 through 12. That from majority of it that's not really a requirement to get to finding the nth term for this type of sequence. And I think it's just going to cause more problems. We're just going to keep it at this for our geometric sequences. Okay. We then have the recursive, finally. I know that was the title. I can't, it looks sloppy right there. So when you have recursive, a recursive is just, now, once again, we can have a recursive arithmetic. And a recursive arithmetic just says that a sub n equals a sub n minus 1, the previous term, plus the common difference. So what I'm saying here is that this is the same thing. You're just taking the same part and you have to state A0 or A1. Some sequences, and you'll see this as your homework, you have to state what the first term is. If you're trying to do it, we just do A1. But sometimes, as you'll see in today's homework, you're given A0, which isn't technically a term of the sequence. It's saying that this is where you're going to start from, A1 being the first term. Remember, A1 is still the first term in my sequence. But sometimes I give you the term before so that you can write the formula. Example, A sub n equals A sub n minus 1 plus 4. I just kind of use 4. Plus 3. A0 equals 5. Find the first 3 terms. What are my first 3 terms? So I'm going to take the term that I have and I'm going to add 3 to get to my next term, or in this case, my first term. So what would be my first term?
Would it be 3?
No, I'm going to add 3. So I'm going to add 3 to the previous term. So here's my previous term. It's not my first term, it's my initial term, or what the term given. What was that?
It's going to be 8.
8. We're going to take 5 and we're going to add 3 to get 8. And then we're going to add 3 to get to my next term. Perfect. And I'm going to add 3 to get to my next term.
20.
Perfect. And then, so it is arithmetic. So when we see this, you don't have to, I'm not, well, I guess there's some practice and problems in changing it. Now, this formula is the same thing as 8 plus n minus 1 times 3. These two are what we would consider equivalent. So this is when you had to do it in your homework, where you had to change from arithmetic to from recursive to explicit. So we call this the explicit, and we call this the recursive. And of course, we still have our same sequence. So they mean the same thing. So when we read this, and this is more so how you'll be doing on your problems tonight. The next one is we have recursive geometric, which is written as A sub n equals R times a sub n minus 1. Given also with a stated a0 or a1. So you're going to state the r0. Hey, get back here. Or you're stating ra1, what the first term is. So for example, a sub n equals 5 a sub n minus 1, and a sub 0 equals 2. What are the first 3 terms? Can I get somebody to, what are the first 3 terms?
The first one's 2.
Perfect. No, the first term is not 2.
It's not.
No, that would be just.
Am I supposed to add the 2 and the 5 together?
No, we need to multiply. It's 5 times. There's no plus. It's 5 times. So what is it?
Is it 10?
Yeah.
5 times 6.
Yeah. So A1 is 5 times A0, which is 5 times 2. So the first term is 10. My next term?
20.
No.
Uh, 20.
No.
What are we on? Is it 5 times 3?
15.
No.
Wouldn't you multiply 10 and 2 now?
So let's look at this formula. The formula says take my previous term and multiply it by 5. So to find A2, I take 5 and I multiply it by my previous term.
Oh, so it will be 50. 50.
50 times 5. There's no pluses. A lot of you are getting 20 because you're thinking you multiplied by the 5 times the 2, but it's really you take the 2 and you multiplied it by 5. So you're just thinking of it in the opposite order. And then my next term would be, again, take the previous term. Gives me
250.
250. All right, and that's geometric. So times 5, because that's what my sequence, my recursive sequence said to do. Yeah, that's why we wanted to do this extra review here. Recursive formulas for neither. Now, what I'm saying on this part is that it doesn't necessarily need to be geometric or arithmetic. We need to know that I can find a recursive no matter how it is. If I give you the formula, you should be able to take the practice and find the term, but you might have to do it a little bit more term by term. Okay, so you have to find A1 and then A2 and then A3. So for example, I tell you that A sub n equals 5n plus 2 A sub n minus 1, and A0 is, we'll start at 1. So this is a recursive formula. This is not arithmetic. This is not geometric. It's just a recursive formula. All right. So when we find this, it is best to find term by term when it was not arithmetic or geo. Okay, so what do I mean by that? Well, let's find A1. So n is 1 here. Okay, so let's find n equals 1. So A1 is equal to 5 times We're using the formula here. Can someone help me walk me through it 5 times?
That's a 20?
Well, I'm gonna, wherever I see an n, I'm going to replace it with 1. So 5 times.
1.
5 times 1. We're not trying to find a term. We're going to find a term. We're going to do all the math. Plus 2 times a sub.
A sub.
1.
Well, yeah, 1 minus 1, but I'm just going to go to 0. All right. In reality, I should have written 5 times 1 plus 2 times, and it turns out to be 1, but it's 1 because its a0 was 1 in this problem. Okay. So a sub 1 is equal to, so let's do the math there. 5 times 1 plus 2 times 1 is?
5 plus 2.
Which is?
7.
7. So there's my first term. Okay. Now, I got to find n2. N equals 2. Okay, I'm going to find the second term. So a2 equals 5 times 2. And be careful on this next step. Plus 2 times
2. Is it 2?
Yeah, there we go. It's 7. Oops, wrong one. I meant to do highlighter. So I use the previous term right here. So I have to, this is where I take my previous term and I plug it in. So it's times 7. All right. So A2 is, that's 10 plus 14, which is? Just doing the math.
24.
24, perfect. And one more time, but let's do n equals 3. So A3 equals 5 times
3.
3 plus 2 times
24.
24. Perfect. So numbers are getting a little bit bigger. You're going to need, you can do it in your head. That's 15 plus 48, so 53, so 63. Of course, you feel free to use the calculator on that type of calculation. We're technology. The adding and the multiplying and the evaluating 5 times 3 plus 2 times 24 is not a lesson objective for us. Getting it to that point and then letting technology do that multiplication addition for us, or the evaluation, is perfectly fine for us. And so my first 3 terms would be 7, 24, and 63. Those are the first 3 terms.